the gentleman. So this morning, I'm just going to kind of do this video to kind of help you through the Running the Race Lab. For those of you that attempted it yesterday after we had collected all of our data, this was, down here at the bottom, this is kind of hiding it, but it says period 2, period 3, period 4, period 5, and period 7 is behind this. I'm currently on the period 7 tab, and this is what I'm going to be using in this example. I'll be using Zach's times here. The only ones that you need to fill in this first chart with, so right here in this chart here, the only thing that you need to do is the average time. We took more data than like the 2 trials, or basically like 1 run. So rather than having just 1 run through here, we actually had these individuals run twice through. And in some classes they ran 3 times. And so we have more data for the 10 meter, for the 20 meter, and for the 30 meter than what this table allows. And so the only things that you need to worry about are these average times, or the things that I've highlighted here. And so each class period, period 2, 3, 4, 5, and 7, all have these times, like the average times for each person identified. And so you only need to pick 4. There are plenty for period 7 to choose from. Some classes only have 3. That's okay. But you need to at least pick 4 to do. And so you'll just choose these 4 here. I just chose the first 4. So I have Zach, Maddie, Elizabeth, and Jesse. And so I've put their average times in. And as you see, if I just go across, Zach, his average time was 2.15, 3.58, and 4.60. And so if I come back to here, we have 2.15, 3.58, 4.60. So these are just the average times, the ones that I've highlighted for Zach. So that's where I put those. And then the second thing that we have to do is this graph here. And so there should be, or I guess if you click on this puzzle piece extension right here, you should have Kami in there. It should say like Kami for Google Chrome or something like that, if it's not just this extension, obviously. And once you get there, you can edit this document. And so you'll be able to add a graph to right here. And to kind of help us through that, I have the graph paper here. And so I'm going to go through this. It's already set up for my example. And again, I'm using these 4 individuals. And so my range for the y-axis, which is going to be my distance, is from 0 to 30. So they all start at the starting line, which is 0 meters, and they all run 30 meters. And so on my graph, here, I go from 0 all the way up to 30. And so that's my full range for the distance. For the time here, I have, again, a range from 0 seconds, because all of them are, because all of them are going from 0 seconds. They all have no time at the beginning. And then the highest time is Maddie. She had walked the whole thing, and so her time is 27.62 seconds. And so my highest time here goes up to 28. That's my max. Everything past here, there will be no data, so I didn't have to number it. And so I just am going to start graphing just Zach's. And then I'll let you graph Maddie and Elizabeth and Jesse on your own, or whoever the other 4 are. But I'm going to use Zach as an example here. So for the first one, if I look at Zach's times, he went 2.15 seconds, and he went 10 meters in that amount of time. So I'm going to come over here in Kami. You can do this in person, like on graphing paper if you would like to, and then just take a picture and attach it with the Running the Race Lab assignment. That's totally cool. But if you choose to do it on Kami, the way that I make the dots is if you go to drawing, I'll use stroke thickness of 6, and then you can just choose any color. If you want to mix up the colors, you can click on more, and they have this whole rainbow that you can go from. I'm just going to use, I'll do red because it might stand out a little bit better. And so I'm going to start by finding Zach's time of 2.15 seconds. So looking at my x-axis, look across, 2 seconds is right here. Each box is 2 seconds. So that means that halfway in the middle is 3. and I know that 2.15 is closer to 2, so it's probably about here-ish. And it took Zach, that's how fast he ran 10 meters in. So I'm going to go from 2.15, and I'm going to drag my cursor up. I'm going to drag my cursor up until I hit 10 meters. And that's where the first dot's going to go. And so that's where Zach's first point goes for this. So 2.15 and 10 meters. The second dot is 3.58 seconds at 20 meters. And so again, I'm going to come back here. I'm going to find 3.58. So again, halfway is 3, and then halfway between that even is 3.5. And so it's somewhere around here. If I go back up, maybe around like there-ish, up to 20 meters, and I click. And so that's my second dot for Zach. And then lastly, we have 4.60 seconds, and that's how fast Zach went 30 meters in. So I'm going to find 4, remembering that halfway is 5, and then kind of going backwards just a little bit over a quarter of the way through that box. I'm going to drag that up to 30, and about here, I believe, is where that last dot is going to go. And so now I have Zach's line. I've plotted all through my dots. I'm going to click on shapes, and there's a line function. I'm going to make sure it's the same color. And I'm going to begin by drawing from the origin up towards the dot. For some reason that didn't go from the origin. Let's try that again. There we go. Up towards the dot. Perfect. And then going from this dot to the next dot. Going from this dot to the next dot. Okay, so there's Zach's line. I could probably make that even a little bit smaller if you wanted to. Like a 2, yeah, 2 is pretty good. I might make that a little bit smaller. But it doesn't change anything. We're still going from the origin to each dot, and then we're observing how the steepness of this line, or the slope of this line, changes. And so it makes sense that the steepness here, or the slope of this line for the first 10 meters, isn't as steep or isn't as vertical as these other ones, because Zach was getting up to his max speed. Then after 10 meters, it looks like he pretty much is going at a constant speed, or the same speed for both, from 10 to 20 and from 20 to 30, because that steepness almost looks like it's the exact same. And so that would make sense. The next thing, once we have all of these graphed, is to flip back to our Running the Race lab. And down here on question number 6, what it's asking you is that you want to go from the 0 to 10 meter mark. You want to go from the 10 meter to the 20 meter mark, and then from the 20 meter to the 30 meter mark. So that's what each of these columns is looking for. For these runners, for mine, I would have Zach, I would have Maddie, Elizabeth, and Jesse. And so those would be all the times. And so rather than just coming up here and copying Zach's times down here, what I'm going to do is, yes, I'm going to copy really fast, but the reason why I'm copying is not because those are the answers, but because it'll help us out. So if we look at how much time it took for all of these individuals, hold on, there it goes. Okay, so it took 2.15 seconds for Zach to go from the starting line to 10 meters. So this time here is actually fine. Like, we don't have to change anything about that because that's how long it actually took Zach to go from 0 to 10 meters. But this second time here, this is how long it took Zach to go from the starting line to 20 meters. So we want to get rid of the time that it took Zach to go the first 10 meters. And to do that, we're going to subtract away this time from before. So we have 2.15 seconds, and that's going to equal 1.43, I think, seconds. Oops. That right, math? 143. Yeah, that should be right. So the time that it took Zach, if we get rid of this first half, like the first 10 meters, the time that it took Zach to go from the 10-meter mark to the 20-meter mark is 1.43 seconds. And so next we're going to do the same thing here. We want to get rid of all of the time that it took Zach to get to the 20-meter mark, and then we want to know the actual time that it took him to go this last 10 meters. So to do that, we're going to take our last time here, which was from the starting line to the 30-meter mark, and we're going to subtract away the time that it took him to go from the starting line to the 20-meter mark. And we'll get rid of uh, that portion of the race for him. And so now we're just looking at the 20-meter to the 30-meter time. And so this time would be 1.02, oops, 02 seconds. We actually increased in speed at the end as well. And so these would be the times then that you would be calculating the speed with. So for instance, as a reminder, to find the speed is equal to distance divided by time. And so with that equation, we know that it took, like the first 10 meters, that's how far Zach went. We went 10 meters in 2.15 seconds. If I quickly calculate that on my calculator, 10 divided by 2.15 seconds, that's going to equal 4. Zach's speed for this first portion was 4.65, and then we keep these units. So you divided distance by time, and so you keep the units of meters divided by seconds, or meters per second. And so this is our unit for speed for the first 10 meters for Zach. Again, using that same equation, speed is equal to distance divided by time. I'm going to look at how far he went here. So he went 10 meters to 20 meters, and so that was a total distance of 10 meters. And he did that in a time of 1.43 seconds. So again, if I do that really quick on my calculator, 10 divided by 1.43, he went 6.9, oops, sorry. That means that his speed is equal to 6.99 meters per second. Because again, we keep these units, meters divided by seconds. And so that's where we get meters per second. And then lastly, his speed on this last one was 10 meters, because going from 20 to 30, that's 10 meters, divided by 1.02 seconds. So that would mean that his speed is now equal to, and doing that math, 10 divided by 1.02, 9.80 meters per second. And so these would be the speeds that Zach went for each 10 meters, or for every 10 meters. So in the last 10 meters, he actually increased his speed quite a bit. Where's the highlight button? Do I not have it? There it is. So here's his speed for the last 10 meters. Here's his speed for the middle 10 meters. And here's his speed for the first 10 meters. And so then you would do that same thing for Maddie. You'd look at Maddie's times. You'd find how much time it took Maddie to go from the 10-meter mark to the 20-meter mark, just like how we did up here. And then we'll do the same thing for the 20 to the 30 right here. Calculate speed, and then move on to Elizabeth. And so that's just kind of how you go through it. And then, of course, there are reflection questions, drawing some conclusions. And then here you're describing the runner's speeds. So how they fluctuated. So for instance, Zach was slowest in the first 10 meters. Then he increased in speed. He kind of like hit his stride, and then he was fastest at the end. We might see that some students maybe reversed or have other um, trends there. So you could put slowest, like speeding up, or middleist, or whatever, and then fastest there. And that can kind of give us a quick trend that we can see. Average time to reach their max speed. So looking at when their speed was the fastest, up here Zach was fastest in the 20 to 30 meter range, and so the time that it would take him for to get to that will be 3.58 seconds, or somewhere between 3.58 and 4.6. So if you want to put a range, that's totally fine because he hit his max speed somewhere within there. Um, and then lastly, you're going to calculate the average speed for each runner during the entire dash. So you're going to take all of these speeds here, add them together, and to find that average, you divide by how many things you added together. So you would divide by 3. So you add these 3 up, divide by 3, and that will get you the average speed for Zach. And that'll finish up your lab. And if you have any questions, I'd be happy to help you out during class today. But we on Thursday, no, what's the day? Wednesday, we're going to be finishing up this lab. And so if you have any questions at all, let me know, and I'd be happy to assist. Um, but yeah, so hopefully you're able to follow along, and I will talk to you. We will have a lab on Thursday, so join, and we will. I'll make sure that you get um, set right, and you have a. You're going to be working on a PhET, which is like a physics simulation on the computer. But it's essentially the same that we'll be doing during the lab on Thursday. So it should be the same simulate or the same experience. If you have questions about it, let me know. And of course, if you feel like it's not an equal opportunity, let me know as well. I'll talk to you later.